Hello and welcome to our today's session. Today we are going to look at how we can do factorial analysis in SPSS. So factorial Anova analysis is normally used to determine whether there is an influence on two or more independent variables on one dependent variable. So for example, we can look at how a level of education and gender have an impact or effect on somebody's interest on politics. Can also look at whether a jail term or jail days is affected by race and gender. Another thing maybe can look at is how maybe whether individual performance in mathematics or a student performance in mathematics is affected by gender and even the socioeconomic status of the family background. So this is a data set that I'm going to use for this session. We are basically going to focus on jail days, gender and race. So gender as one independent variable and race as another independent variable. So for gender, we have male and female. Those are the two groups for that variable. Then for race, you have white, black, and Hispanic. So to do this analysis currently, simply move your cursor on the Analyze menu on the SPSS main menu. Once you click on that, you go to General Linear Model. Then on the General Linear Model, another menu will be displayed. Then simply click on Univariate. So on Univariate, we have all our variables. Already we have them here. So gender and race. So these ones we are going to move them to the fixed or factor dialog box. Then on the jail days, we move them on the dependent variable box. Then simply click on OK. Two tables will be generated. We have univariate analysis of variance, where we have value level and gender, male we have, and female, as that is for the number of ends that we have for that particular entry. So this also applies to race, where we have white, black, and Hispanic. So we have also test of between subject effects, whereby we are going to determine whether there's a significance level of difference for one independent variable and the dependent, that is jail days. Then also going to look at the race, which is also another independent variable, and the jail days as the dependent variable. Then you have the two independent variables combined and their effect on the dependent variable, which for this case is jail days. So looking at this table, you can see that gender and jail days, they were significantly different because the p-value was less than the significant value of 0.05. So here this as 0.001, which is way below the significant value of 0.05 at 95% confidence level. So for us, we'll simply have the significant value of 0.0, but when reporting, we can't say P is equal to 0.005, but we can say P is less than 0.01, simply because we have all the zeros all through. Then if you have now the combined variable for gender and race, then we have all of the two here. The p-value is less than the significance value of 0.05. That's how we are going to report for each. So we can say a factorial ANOVA was run to determine the relationship between these two, the independent variable and one independent variable. So we can copy this. We can cut, then come and paste in our word here, where we have we are going to do the interpretation for this kind of data. So we can just auto-fit this to window just to have it well represented. So starting with the first one, we have race. So for race, factorial ANOVA was run to determine whether there's a significant difference during the year after graduating record for race. So in this case, we find a statistical significant interaction between the effects of race on gel days, and we are going to report also the F value. So our F value for race is 9.676, significant value less than 0.01, and the degree of freedom is 2. So we are going to have F in bracket 2, a 9.676 as our F value, and the P value is less than 0.001. So our P value here is less than 0.00. You can't say P value is equal to 0.0 because simply we have the 0 values all through, then we can only report it as less than 0.001. Than 0.01. So the same way will appear to gender. There was when we ran that analysis, we found there's a statistically significant interaction between the effects of gender on gel days, and we have our degree of freedom of 1, and our F value, degree of freedom for gender is 1, and our F value is 11.744. Significance value of 0.01, shares that is going to report. It was significant because it was less than 0.05 at 95% confidence level. So if we now compare race and gender, the two independent variables combined, and their effect on the dependent variable, then we'll find there was a statistically significant interaction in the effects of race and gender on gel days, and our degree of freedom is 1, and F value of 12.190, and the significance value is 0. P value is 0.001. So that's significant because the value was less than 0.005, significant value of 95% confidence level. So this marks the end of our tutorial for today. So if you found this video interesting and insightful, kindly click on the subscription tab below and subscribe to this channel for more updates on the same.